My work is mostly associated with protein quantification, extraction, and its functionalization. And today I'm going to talk about harnessing protected cultivation for high value crops to achieve nutritional security. I believe that all of you are very well aware of protected cultivation. So we'll do a very small understanding concept of that, but mostly focus on how we can improve nutritional security through protected cultivation. So one thing that I want to introduce to everybody is the concept of hidden hunger. We all understand that India back in 1970s and 80s, we were not self-sufficient in food, especially in our post-independence time. But then Green Revolution happened, and if we consider today, we have a lot of food available to fill everybody's stomach. Every Indian has enough food to eat that you would not feel hungry. But then more than 50% of Indian population suffers from many different minor or major morbidity kind of diseases, which have been related to a concept called as hidden hunger. That means even though I'm not feeling hungry, I have enough food in my stomach, and I've been well fed. There are some specific nutrients, mostly micronutrients, specifically vitamins and minerals, which my diet does not have. And a major reason for that is that Indian population is now very much into consumption of cereals. To a certain extent, some pulses also, but our consumption of cereals, fruits, and vegetables, particularly, is very, very low. If you look at the dietary guidelines, it is recommended to consume at least 3 to 4 servings of fruits and vegetables per day. And I believe all of us, even if we look at ourselves individually, we know that probably none of us is actually consuming that much per day. So this is the reason why this hidden hunger is prevailing at a greater scale in Indian population, especially our younger generation, when we are moving to more processed products like having breads and pasta and more of burgers and sandwiches and those kind of products. But we have moved away from salads and eating a colorful plate. And hidden hunger is a big challenge that not just India, but globally the countries are facing, because it also has its own economic impact, because per person's work output also reduces. And it also has a very big impact on medical bills that Indian population is experiencing. So basically, hidden hunger is defined as the chronic lack of micronutrients. And it does not start for humans only from the diet, but it starts from plants. Our soil is devoid of getting over a period of time has got devoid of many minerals because of repeated agriculture and utilization of harder pesticides and fertilizers. The natural chemistry of the soil has changed, and basically most of these micronutrients, minerals, are not as easily available as it used to be early on. That affects the plant health. Our plants, basically what we try to consume, fruits and vegetables, then do not have adequate packaging of these micronutrients, and consumption of those kind of products to humans does not yield bring out those micronutrients to human diet. And in case of humans, when we take this concept, it has been linked, this deficiency of micronutrients has been linked to many different growth and metabolic diseases. It impacts the brain and muscle function. It impacts the immune system. It impacts the fetal development. Like for an example, if we just talk about a woman getting pregnant in India, the first medicine that the doctor prescribes is consume folic acid. It is mandatory for every pregnant woman in India to be taking a tablet of folic acid for the entire duration of pregnancy. If we look at that, now folic acid is something which is very, very important for neural tube development. Basically the nervous system development of a fetus. It becomes very, very important. Now, if we go to the Western world, if we talk about Europe and if we talk about United States and those countries, there the wheat flour basically is already fortified. It is mandatory for those countries to fortify wheat flour with these micronutrients. That mandatory fortification program does not exist in India. And so when these kind of deficiencies come, they are getting more and more prevalent in India than those countries. Hidden hunger is basically affecting over 2 billion people worldwide. So it is a really big problem. More than 1 million children under 5 die every year from vitamin A and zinc deficiency. So these micronutrients, even though a person is not feeling hungry, is draining energy and is draining the metabolic behavior and metabolism of a human, and is not yielding out the best health that a person, and specifically a toddler or a baby, should experience. And it has been directly this micronutrient deficiency. The earlier concept, which we all probably know about, was protein energy malnutrition, when the focus was that marasmus and kwashiorkor were two major diseases, which, when we talk about children under 5, was a major concern. Over the years, the availability of protein and carbohydrate, basically energy giving and bodybuilding foods, has increased to a good level that today most kids are able to consume that diet. But now the focus of the shift has changed from protein and energy, basically calories and protein, to micronutrients. And earlier, kwashiorkor was related to stunting, which is that a child is short for its age or height, short for its height. Now, the same thing is, even though there is enough protein in a child's diet, it has been focused that children are still stunted because of this micronutrient deficiency. So, how do we get people to consume more micronutrients? See, the strategy is simple. We have food. If you look at the food chart, it has been described into three major food groups. We have the energy giving foods focusing on carbohydrates and fats. Then we have bodybuilding foods, specifically proteins. And then we have protective foods, which focuses on minerals and vitamins. And for these two components, minerals and vitamins, fruits and vegetables form the most important contributors. We do not have these such densely packed in other food sources. But not just the diet pattern, even the fruits and vegetables that are available for Indian consumers today are not of as good and as high quality because of numerous impacts. If we just talk about agriculture and the way things have changed over the years, global warming is a major concern. Fruits and vegetables need slightly colder temperatures, most of them. The environmental concentration of carbon dioxide is increasing, again contributing further to global warming. The weather shift has been very, very significant. The rain is erratic. Sometimes it happens too quickly, too much of rainfall happens, and then there are longer dry spells. So all of this has impacted the soil quality and the agriculture output. If even though the quantity of produce is increasing year by year, the nutritional density of the produce that we are having is decreasing, and that is a challenge. The tomatoes that we get today are probably not as nutri dense as they used to be. Now, the reason is multifaceted. There is altered weather effects which affects the growing season, and there is not adequate supply of water. Extreme events such as hailstorm or extreme rainfall at a sudden time is also impacting the produce. Elevated carbon dioxide reduces nutritional value and increases its pest resistance. Climate change also impacts soil biodiversity, pollination, and then land quality has been decreasing. Water quality and quantity both are being impacted. So all of this together, even though when we say, okay, per unit land area, our production has significantly increased, but the nutritional density of the produce that we are having, the quality of produce that we are having, specifically for Indian population, is probably not as good. And for this, protective cultivation has a really good scope of how we can make our produce nutri-dense. So the same tomato grown outside versus grown inside, a protective cultivation setup might have different nutrient composition besides all the other quality attributes. That is also an important concept that we will be delving in today to understand how protective cultivation is supporting the nutritional status of the society. So, what is protective cultivation? It is a method of growing crops in a controlled environment to ensure optimum growth and yield. If we talk about just plants, we need a bigger plant. If we talk about leafy greens, we need bigger leaves, more denser foliage, more stronger structure of the plant, and more crispy, and all of those things, more fresh, but at the same time also more nutritive. This is particularly beneficial in regions with unpredictable weather, such as water scarcity is there, or there is limited arable land, and vertical cultivation is something that we need to look at. The main objective for protected cultivation is to shield the crops from extreme weather, pests, and diseases so that we can keep out the insects, flies, and all of those things out and away from the area where our agricultural production is growing. And it promotes better quality produce. And this is something that I want to introduce to all of you right now. There is something called as aggregate nutrient density index. Now, this is an index which is used to categorize food products into how nutri-dense they are. See, we already know that something which is rich in carbohydrates, it is giving us 4 kilocalorie per gram of energy because it's carbohydrate. Then proteins also have about 4 kilocalorie per gram. Fats basically give us 9 kilocalorie per gram. Fruits and vegetables per se are not rich in proteins. They are not rich in fats, and they are also not rich in carbohydrates. They do have sugars, soluble sugars, smaller sugars, monosaccharides and disaccharides, and they contribute very significantly to the flavors, but they do not have a higher amount of starch or those things that we consume them for energy in general. We consume fruits and vegetables for their micronutrients, the vitamins and minerals. So aggregate nutrient density index is calculated by taking into account the amount of these micronutrients such as vitamins, minerals, and certain phytochemicals per calorie that food is going to give. So we are not focusing on protein or carbohydrate, but micronutrients. And if we talk about aggregate nutrient density index, fruits and vegetables are rated higher, even higher than egg, because they have much higher density of micronutrients compared to the amount of calories they will be providing. For an example, kale, which is, I guess most of us know that kale is known as a superfood. It has an Andy score of 1,000. And if we go further, we can see that most of the green leafy vegetables have a very high aggregate nutrient density index. That means they are even though they're not providing too much of calories, but they are very dense in micronutrients. And so protective cultivation, the goal is to not just make better quality produce, not better quantity, not better size, better color, all of those, but as well as better nutritive. Protective cultivation is basically a sustainable approach to horticulture as it enhances the nutritional security by providing high value crops. It has multifaceted objectives. First, obviously, is increased yield. And there have been numerous researchers who have evaluated different crops, compared them from open cultivation to protected cultivation, and have given different results that over a range of 40 to 150% more production has been obtained if the cultivation is done under protected conditions. Then improved quality is another thing, that the produce quality is better in protected cultivation. Pest and disease management, we understand that protected structures, they can reduce the pests and diseases because soil-borne pathogens and all of those things, the insects and flies do not enter, nematodes are kept out of the system. So it kind of protects the pests and do not get them in contact with the agricultural produce. Another good thing with protected cultivation is that we can go for year-round production. Because it is done in controlled environment, we can control the temperature, the humidity within the system. Obviously, it is expensive, requires those inputs, but the year-round production of crops can be done under protected cultivation. And it is also resource efficient. That means we can focus on how much of water a particular plant needs and target it very, very precisely. It can really support precision agriculture. So basically, the output that we can get using a protected cultivation setup is sustainable local production. We can go for year-round production, higher crop yield, better water efficiency and resource efficiency in general. We can also focus on organic, non-GMO and low pesticide produce because pesticides are used to kill pests. If we can keep them out by using the protected structures, probably we would not need to use those many pesticides. And then better quality control, better predictability, because everything, when something is quality controlled, we can understand what wrong might have happened. If some plant is infected, then we can see the symptoms and very, very quickly we can react to it and change the conditions of the agricultural system to bring back the conditions to normal growth again. Something which cannot be done in open cultivation setup. Now, how all of these things are helping, if we look at it individually, Elevated carbon dioxide, if we see in the environment, it is within the system. If we are able to do, if we are able to do so, what it has, people have observed this, that it can promote better produce. It has also been shown to increase sugar and altered nutrient content, enhance the sensory quality of produce, and accelerate the maturity. Also improve residence of biotrophic pathogens, and reduces the requirement of chemicals for insects and pests. For an example, if we can focus just on water quantity, this is a research done by Garuda et al. This is very recent publication of 2025. If we actually see this, if we give full how the impact of water is affecting the quality of the produce, not just the size of the produce. Fruit size definitely has a visible impact compared from deficit irrigation to full irrigation. But besides that, better yield, simultaneously improved texture, better firmness, better color. That means the quality of visible quality of the produce. The total soluble solids, total sugar content, solid to acid ratio, sugar to acid ratio particularly, protein content, they are also much well balanced. And if we talk about micronutrients, specifically vitamin C, carotenoids, lycopene, which is also a type of carotenoid, beta carotene, flavonoids, the quantity of these can also be increased when a crop is not stressed. And to make something not stressed can be done better in a protected cultivation setup. Now, high temperature, which is a big concern, global warming is a big concern these days, is impacting agricultural productivity. Focusing, if we focus on fruits and vegetables, particularly in many of these aspects, high temperature is contributing to decreased yield, increased enzyme activity. Increased enzyme activity means the shelf life of the product reduces. It is ripening very fast. It is getting older very fast. There is oxidative stress. That means there can be high temperature is also contributing to free radical damage. Reduced antioxidant activity, again contributed by the free radical damage. Hormonal changes within the produce, transcriptional changes, water loss, reduction in plant growth, reduced photosynthetic activity, and DNA damage. All of these are contributed due to increased temperature. So if we can go for protected cultivation, most of these can be minimized or to controlled to a different level, and we can maintain good quality produce. Now, this is something that we need to understand. We have talked about the effect of carbon dioxide. We have talked about temperature. We have talked about water, gas composition. Basically, everything that a plant experiences during growth, if we can control that, we can impact its quality. But what is the use of this quality? Ultimately, the goal of better production is consumption. Humans are supposed to consume them. And I have already given you some idea about the upcoming challenge in human health, which is hidden hunger. Now, to tackle hidden hunger, see, it is very difficult to make people consume higher quantity of fruits and vegetables. But these high density, nutrient rich fruits and vegetables can be used as a source of functional foods and nutraceuticals. So, to introduce this concept to you, functional food is something which is having which can render health benefits to a consumer beyond basic nutrition. Basic nutrition is same: protein, carbohydrate, fat. Now something that has components which is supporting human health beyond that basic nutrition is a functional food. For an example, if I take tomato is very rich in lycopene. Lycopene is a carotenoid, and it does not have a provitamin A activity or anything, but it is a very potent antioxidant. And it, any questions? Anybody?
Uh, Hello, ma'am. Ma'am, we will take questions at the end
Okay, sure.
so that you will not get distracted.
Okay, sure, fine. So functional foods are something which are rendering benefits to the consumer beyond basic nutrition. Now we need to understand tomato has good quantity of lycopene. It is very potent anti-cancerous agent, and so tomato by itself is a functional food. Now, since it is very difficult to make people, especially kids these days, to eat tomato generally, what we can do is if we can extract lycopene from, say, tomato and then add it to another product which is generally consumed. For an example, okay, I added that lycopene into some bread. Now, bread is also consumed as a food. What we have done is we have made bread into a functional food, a processed functional food. Another category of these functional components is that if I extract that lycopene from tomato, but instead of adding it to another food product, I am making a capsule or a tablet out of it, or say a tincture out of it, a syrup out of it, like a medicine, then it becomes a nutraceutical. So I hope we understand this concept or difference of functional food and nutraceutical. Functional food is a food component, eaten and consumed just as food is. Nutraceutical is again functional component derived from a food source. Basically, it is a nutrient, but is now consumed as a medicine. Horticultural crops, specifically fruits and vegetables, like I've been saying from the beginning, are particularly appealing as functional foods and nutraceuticals, even though even their waste products, which are not very edible, are also very rich in nutraceuticals. Now, why do we need all of this? We have always studied about proteins, fats, and carbohydrates. Now, where is this concept of lycopene or anthocyanin or all of these is coming from? Why do we even need it? The issue is oxidative stress. Every human, basically every organism, because of the changing environment, because of the rising temperature, because of the rising pollution levels, we are all experiencing oxidative stress. If we go back 50 years from now, probably cancer was not that big of a disease. But now it is getting common. Heart diseases were not as prevalent. Cardiovascular diseases, coronary heart diseases, stroke. These did not used to be problems of the past, but now their incidence is increasing at a very greater level. And the reason for this is attributed to oxidative stress, which basically represents an imbalance between the production and the quenching of free radicals or reactive oxygen species. We need to understand that in normal circumstances, humans, animals, plants, all organisms are exposed to oxidative stress. And under normal circumstances, our body naturally produces antioxidants, and also through diet, we can consume antioxidants and can tackle that oxidative stress. As long as the production of those free radicals and quenching of free radicals is in a balanced state, there is no oxidative stress being experienced. So, if that is the situation, diseases like cancer and all would not happen. The problem arises when oxidative stress increases, but our body is not able to manage those generated free radicals because maybe our diet does not have enough of those micronutrients. And that is why consumption of these micronutrient fruits and vegetables in the present scenario is very, very important, because the external factors that were causing oxidative stress have increased. See, we also need to understand that living in metro cities, surrounded with so much of pollution, is a challenge. True, but even if somebody is not living in a metro city and is living in very clean mountain region, close to forest and all of those things, then also the production of free radicals happens within the body during the normal course of electron transport chain, which is basically the energy generating step of glucose metabolism. We go by glycolysis, Krebs cycle, and electron transport chain. In the electron transport system, free radicals are generated. But in general normal circumstances, they can be tackled by human body. But with increasing pollution levels, that imbalance is increasing. And so, to bring the balance back into the picture, our diet should now be more densely packed with micronutrients. And when we talk about these micronutrients, specifically antioxidants in fruits and vegetables, this is the range of those. Ascorbic acid, which we all understand as vitamin C, is a very good antioxidant. Carotenoids is another category, principally classified into two categories, carotenes and xanthophylls. So our fruits and vegetables are very rich in carotenes. Xanthophylls resemble carotenes, very similar in the structure, except they are oxygenated. Xanthophylls are rich in cereals and pulses, mostly in the outer layers. And we all understand that milling basically get rid of the outer layers of cereals and pulses. So cereals and pulses, even though they have xanthophylls, they're not coming to human diet unless we are consuming whole grains. Then another important antioxidant is vitamin E, popularly, which is also known as tocopherol And then fruits and vegetables are very rich in phenolics, which is one of the largest known groups of antioxidants. It encompasses benzoic acid, cinnamic acid, all the different kind of flavonoids, and many other lignins and lignans. So these are the different categories of components that fruits and vegetables have generally, and which are very good antioxidants. Now the goal is to use protected cultivation and try to make our produce more denser in these antioxidants. So, like I gave you an idea, basic foods can also be functional foods. Carrots are functional foods because they are very rich in beta carotene, which is a good antioxidant. Oat bran cereal is also a functional food because it is rich in beta glucan, which is a very good dietary fiber, can really help keep digestive health in track and prevent all the cancers associated with digestive tract. But we can also make processed functional foods. For an example, calcium enriched fruit juice. Fruit juices are, if we talk about orange juice by itself is not going to be rich in calcium. But see, people want to consume orange juice with breakfast and not milk anymore. That means for food scientists, to make people have that calcium, why not add calcium to fruit juice rather than forcing people to consume more milk, because that trend is anyways changing. So a fruit juice that has been enriched with calcium now becomes a functional food. Similarly, but if we extract a particular component, say I extracted I extracted isoflavones from soya, and then I am making a tablet out of those isoflavones, or I am making fish oil tablets such as DHA and ALA, which are omega-3 fatty acids. Omega-3 fatty acids are generally almost non-existent from the plant food side, and are very, very important for brain development, especially kids. Fish and algal oils are very good source of that. So if we can extract algal oil and fish oil from the specific organism and then add those into processed products for some other people to consume, it becomes a functional food. But if I add that into a tablet and make a person consume that tablet, then it becomes a nutraceutical. There are many different categories, like I've briefly explained you, of those functional foods. For an example, carotenoids. We have alpha carotene, beta carotene. Our major common sources are carrots, fruits and vegetables. They can neutralize all free radicals. Lutein is a very potent anti-carcinogenic agent, antioxidant. Similarly, lycopene, very, very densely packed in products like watermelon and tomato. That is why they are red in color. Lycopene, the tomato and watermelon, persimmon, these are red in color because of presence of lycopene in them. This slide basically represents small microstructural changes between lycopene, alpha carotene, and beta carotene. If we see the structure of alpha carotene and beta carotene, they resemble the structure of retinol, which is vitamin A. Vitamin A is very, very important for eye health. Deficiency of vitamin A can lead to night blindness, and prolonged deficiency can even lead to complete blindness. So alpha carotene and beta carotene are vitamins, technically, because they can be converted in human body to vitamin A. Lycopene has no such benefit. It is an open ring structure. It is not provitamin A in human body. It cannot be converted into vitamin A or retinol. So earlier on, scientists used to think that lycopene is not a necessary food component. It has no nutritional benefit. But over a period of time, we have realized that this particular component can render health benefit beyond basic nutrition, making it a very important functional food. Then we have the other category beyond carotenoids. We have phenolics, where we have anthocyanins. Anthocyanidins are basically proanthocyanins. Catechins, very common in tea. Flavones and flavonoids, basically flavonoids. Lignans, again, they have all been evaluated with many different types of cancers and have shown very strong relation as anti-cancerous properties. Some polyphenols are lipid soluble, but mostly they are water soluble. Tea is also very, very rich in catechins, specifically green tea. Green tea is also very, very densely packed with antioxidants, and so we should be consuming them. Now, this is a general structure. Like I showed you, this is the general structure of carotenoids. This is the basic structure of flavonoids. So, many different categories, very small structural changes can lead many different ones. For example, flavones with a single double bond. flavonoids with a double bond here and flavonoids a bond here, flavonoids with a double bond here and here. That is how small structural changes are giving out many different components. They all are very, very active antioxidants. And this antioxidant potential basically comes from their structure only. Because they are phenol rings, they have this tendency of delocalizing the electron. So if a free radical comes into the picture, the free electron of that free radical basically gets delocalized in the flavone structure itself and is basically unreactive to the DNA, to the cell, other protein, to the lipids of cell. It does not in fact impact the metabolism of the cell otherwise, and thus this is how the structure is giving antioxidant potential to these components, making them functional components. Similarly for tannins and lignans. So if we talk about phenols and polyphenols, there are about 8,000 compounds belonging to the flavonoid family, and they've all been found to be related, giving health benefits to different categories. Tannins, they can be anthocyanins and proanthocyanidins are also of the same category. They're found in different sections of the fruit. They can be present in the peel, they can be present close to the seed coat, they can be present in cereals, nuts, wine, tea. And although for the plant structure, their role is to give the color to the produce, and also because of slight astringency and bitterness, they're also plants' defense mechanisms against pests and animals basically. But when consumed by humans, they are really good antioxidants. And this is what I want to convey to all of you, that our diet should include more densely packed, more colored fruits and vegetables, so we can have a blend of all these carotenoids, phenols, and different types of antioxidants, so that they can target different kind of lifestyle related diseases in human body. See, something that we need to look at specifically in the Indian context, and now more specifically in the Indian context, that are we aging prematurely? Like if we talk about America, they have an average life of 74 years. But the last 10-12 years of their life is very, very dysfunctional. Same thing that we experience in the Indian population also. Even though our average lifespan has increased drastically post independence, but the later ages of human life are not very, very active. So what should be the goal? Is the goal only to reach 100 years of age, or the goal is to have not a long life but a long healthy life, a concept which is known as longevity? So scientists these days are really working on how to reach longevity rather than just a longer life, a more functional life, more active life, when we are not dependent. The last 20 years of human life are very, very significantly associated with degenerative diseases. The reason for those degenerative diseases are free radicals. All of this, which is basically increasing the oxidative stress and resulting in cancer, aging, diabetes, cardiovascular diseases, and other health conditions. But if we can manage this free radical by consuming these nutri-dense, functional product-dense food products, humans can well off live over 100 years. As people in centennial, like we have many people living over 100 years in the Japanese side of the world, because their produce is actually, they eat a lot of salads, they eat a lot of fish products. Their diet is very rich in omega-3 fatty acids and not as rich as saturated fatty acids like we in India do. So this is something that we need to understand of why these functional components are very, very important to be included in the human diet, and how protected cultivation can contribute to it. Many researchers have worked on it. Now, this is a paper that I want to show to you, wherein the idea was not to see whether how controlled light is affecting the growth of plant, which we can clearly see here. When we take natural light, which is about 80 micromole per meter square per second, with and without fertilization, what we see here is by the time we are increasing the light intensity, without additional fertilization, the plant growth was better than with fertilization. That means the need of fertilizers has been negated if light intensity has been controlled, which can be easily done under protected cultivation. And it is not just about the foliage size of this particular crop, but even in lettuce, Again, we see here that without additional fertilization, the plant growth was much better than with fertilization. Whereas at natural light, it was not the case. That means fertilization improved under natural light, but we did not need that fertilizer input when light intensity was increased. And this is not just about the plant structure and the shape and the yield, but also about the nutrient composition. So the same paper also evaluated the total phenolic content and the total anthocyanin content. And here also we can see that 150 and 250, these two lines, basically this and this were giving better micronutrient density in produce compared to the natural light systems. So if we talk about natural light systems, A and D fertilizer really increased, but after that the significance of fertilizers declined, and even just light intensity could make the produce more nutri-rich. We have also done similar. This work was done in Indian Agricultural Research Institute. My colleague Dr. Alka Joshi has worked on tomatoes on similar lines that I just show you, wherein we evaluated the nutrient composition beyond all the physical quality parameters. We also evaluated the nutrient quantification of different tomato varieties in open field and polyhouse condition. And if we see here, most of the varieties, if we specifically look at lycopene content, because that is the functional component, we can see that lycopene concentration under polyhouse condition increased in most of the varieties. That means if the plant is not exposed to stress systems and can be is grown under controlled conditions, we can not only improve the yield of the produce, but also improve the nutritional composition of the produce. And then on consumption of this produce by humans, we can basically tackle a lot of lifestyle diseases. This work also has been done in IARI, wherein we have evaluated the bioactives of capsicum, different lines of capsicum at different stages of their maturity. So we need to understand how good growth is also impacting the composition. So this is just how capsicum appears. Different lines of capsicum appears at the raw stage, at the color turning stage, and at full maturity. And this shows how much is the composition changing. So if we see at full maturity, the amount of flavonoids significantly increases. Similarly for total phenols. And this has this increasing content of flavonoids and total phenols has a direct impact on percent DPPH inhibition, which is basically an idea that gives us antioxidant potential. So we can see at full maturity, protected cultivation crops had very high antioxidant potential and also higher ascorbic acid content. Lycopene content, if we see the red fruits, like I tried to tell you, if we see at this chart, Lakshmi and the first one and the fourth one are the red varieties. Red directly correlates to lycopene, which is our very potent antioxidant. And if we see the lycopene content here and here, S6 and S16 have very high content of lycopene. Our yellow variety, lycopene also falls under total carotenoids. So if we see if we see our yellow varieties, number 7 and number 12, 7 and 12, they are also rich in carotenoids, but not as rich as in lycopene. So this is something that we need to understand, that different cultivars, given different conditions, we can alter the nutrient density of the produce. Now, protected cultivation also gives us a very good new novel technique of improving the quality of the produce, such as nutrient film technique. Now, what is happening in this case is, this is basically a hydroponic system wherein there is a medium, water basically, which has been enriched with nutrients, and this is circulating. Basically, nutrient is being pumped from the reservoir close to the plant. It is flowing over the roots of the plant, so the plants can take the required nutrients, and we can make basically our produce rich in zinc, iron, and iodine directly in the crops. And then the excess nutrient can be returned back into the reservoir. This technique is also being used in these days in hydroponic systems, wherein we can basically input specific micronutrients into our plants for producing healthier produce. And this is the overall strategy, that this is the overall strategy of how protected cultivation and even these small micronutrients are affecting the growth of plants. If we can provide a plant with higher amount of calcium then or potassium, then it can increase, make the produce better firmness, dry matter content can increase, shelf life can be better. What nitrogen input to the nutrient medium can do, what magnesium input can to the nutrient medium can do, all of this has been evaluated, and how produce is impacted, and all of those micronutrients can be enriched into a particular produce. Like we can have tomato or we can have green leafy vegetables rich in vitamin A, B, and C. And also by using this nutrient film technique, we can make the plant take up more iron, more selenium, more zinc, more calcium. And once they have taken up more, they are basically locked into the plant structure and on consumption can be made available to the humans. So these are different strategies and some of the work that we at IRI are also doing to make the produce not just increased quantity and better quality in terms of sensory, but also better quality in terms of nutrient properties to tackle the upcoming problem of lifestyle diseases and hidden hunger in our populations. So thank you. This is what I wanted to bring to all of you today. And if you have any questions, we are open to discuss.
Participants, please ask your questions. Hello?
Hello.
Yeah, please ask your questions. Microphones are turned on now. Kindly ask the questions.
Hello.
Hello.
Uh, Good evening, ma'am. Good afternoon, ma'am.
Yes, good afternoon.
Uh, First of all, excellent presentation, ma'am, and happy Holi to you and all.
Thank you so much. Happy Holi to everyone.